Subtraction of real numbers. When talking about subtraction, it's not really any different than any of the subtraction you have ever learned your whole life. What becomes more difficult with subtraction is when we start dealing with negative numbers. So what we have to help us is the subtraction rule. To subtract b from a, add the opposite of b to a. And hopefully this sounds familiar, because instead of saying add the opposite, which is definitely okay to say, we all remember this phrase. Keep, change, change. The example they give here, we might look at 3 minus 5 and know that's negative 2, but we want to practice changing subtraction to addition for when we're working with variables. So you can either think of it as adding the opposite, or if you go keep, change, change, you keep the first term, 3 stays the same, you change your subtraction to addition, and you change 5 to its opposite. Now if it's already addition, you don't want to change it. It's only when it's subtraction. So again, keep, change, change helps us to remember that. If you look at this expression here that says evaluate, and whenever we see the word evaluate, we know we have to get an answer. Do I know you can type this into your calculator and get the answer? Yes. But again, you need to practice changing subtraction to addition, because when we start dealing with variables, you can't type those into your calculator. So if we wanted to change this to addition, we'd keep the 10, change the minus to a plus, change 5 to its opposite, which is a negative 5. I write it in parentheses just so we don't get sloppy and go plus, negative, and can't really tell. If you look at the next part of our expression here, it says plus 14. Since it's already a plus sign, leave it alone. We want it all to be adding. Okay? So now we keep the 14, we change our minus to a plus, we change negative 18 into positive 18. So now when we add these, 5 or 10 plus a negative 5 is 5. And if you wanted to add this down here, it doesn't matter the order again. Commutative property says we can change the order of adding. 14 plus 18, I believe, is 32. And then if you go 5 plus 32, you should get 37. Again, this is not any different than what you've learned in the past. Finding the terms. I ask you to think back to what terms mean. The definition of terms is the parts of an expression that are being added together. The parts of the expression that are being added together. So if we look at the expression 3x minus 5, nothing's being added. And if you think, well, it's not a big deal, it's being subtracted, and you list your terms as 3x and 5, you'd be wrong. Need to be added together. So to list terms, we have to make sure everything's being added. So if we go keep, change the minus to a plus, change 5 to a negative 5, your terms now are just what's being added together. 3x is being added to negative 5. So your terms are 3x and negative 5. Is it important that it's negative? Absolutely. If you just have a 5 there, it will be marked wrong. Talking about, again, evaluating and functions. We're given a function here, y equals negative x minus 7, and then it gives us the values of x, negative 2, negative 1, 0, and 1. These are your inputs. This is your domain. It says organize your results in a table and describe the pattern. Well, if you want to create a table, we just make an input-output table. So we're going to input the values of x, negative 2, negative 1, 0, and 1. And we're going to put it into this function. Y equals negative x minus 7. It might be easier if you go keep, or even add a 1 in here if you want. Keep, change, change. Okay, again, you don't necessarily have to do that, but you have to be careful not to forget that this is minus or a negative. So all we're going to do now is we're going to take our x's there and substitute them in here. So we'll get negative 1 times negative 2. That's why I like putting the negative 1 in there. You don't forget then that it has to be a negative negative 2. And then we add negative 7. Negative 1 times a negative 2 is a positive 2. Positive 2 plus a negative 7 is a negative 5. Do the same thing for this one. Plug it in for x. So we have negative 1 times negative 1 plus a negative 7. Negative 1 times negative 1 is positive 1 plus a negative 7 is a negative 6. 0. Negative 1 times 0 plus a negative 7. Negative 1 times 0 is 0 plus a negative 7 equals negative 7. And finally 1. Again, we're just substituting things in here for x, our input. We have negative 1 times 1 plus a negative 7. Negative 1 times 1, negative 1. Negative 1 plus 7 is a negative 8. Okay? So if you look at this table here, and we could put our y column here. This is our outputs. I know they're listed here. We could have just put it over here to start. This is our range. This is all our outputs. Now it asks us to describe the pattern. So if we look at these over here, notice what's happening every time we add an x. Okay? As our inputs, you could say, or as our x's, as our inputs increase by 1, what's happening to our outputs? Because we're going up by 1 every time. If you look at here, what's happening to these outputs? Our y's, or you could say outputs, doesn't matter. Hopefully you're seeing that they decrease by 1 because they're negative. They're getting smaller by each time. So again, just a pattern you want to look as what the first thing is happening. As your x's are increasing, what's happening to your y's.